In what is likely to be the final video, I mean at this time, or the final recording for this week, I want to highlight some of the key elements of this idea of regulation being a multimodal concept, which is actually returning us to Lawrence Lessig's ideas in his book. Originally it was Code and Other Laws of Cyberspace. There's a version 2 which is more recent. Unsurprisingly, it is open source and available too if you want to have a look at it. Basically, in a nutshell, Lessig's Code is Law concept basically is the idea that, and it's a pretty simple idea when you think about it, that there are many different things that drive the way that humans behave. And the way that something is coded in this internet world may in fact be a really good way of driving behavior. So those of you who are interested in behavioral economics will be well aware of nudge theory and habit forming theories, where essentially research and steps have been put into the user experience with a range of different products and services designed to influence and impact the way that we interact with these technologies. Probably one of the most famous of these was Instagram inventing doom scrolling, basically setting up a user experience that didn't matter how many times you swiped, you never ran out of content, basically providing those little endorphins that keep people connected to their devices. And look, that's another way of thinking about these concepts. Essentially, Lessig's theory, and Lessig is a professor at Harvard Business School, by the way, Harvard University. He's a law professor, Harvard Law School. For those of you who are interested in him and what he has done, he appears a lot in a now quite old documentary called The Internet's Own Boy, which is not for the faint-hearted, actually. It's really emotional. I won't give too much away, but it really does raise a whole heap of ethical and considered issues about the way that the internet should work and what does happen, and the role of commercialization and the role of regulation in the internet generally. So Lessig's argument is, in a nutshell, that in cyberspace, the architecture is the dominant and most effective modality to regulate behavior. The architecture of cyberspace is code, so the hardware and the software that creates the environment in which the internet operates. Code is written by code writers, so it's code writers, especially those from the dominant software and hardware houses, which, when he wrote his first book, was Microsoft and AOL, who are best placed to govern the internet. Of course, since then, we've seen the rise of the platforms, particularly Google, Meta, so Facebook and Instagram, and of course Microsoft is still there, and with ChatGPT and AI-enabled versions of Bing, it's likely that Microsoft's influence is only going to increase. From the very beginning, Lessig has argued that code is law in the imperative sense of that word. Code determines what you can and you can't do in cyberspace. So the crux of his theory is that law can directly influence code. Governments can regulate code writers and ensure that the development of certain forms of code are promoted or prohibited. Effectively, law and those who control it can determine the nature of the internet, the nature of the cyberspace environment, and as a consequence, indirectly, they can determine what can and can't be done there. Clearly, this has already been done. Code has been used to rewrite copyright law. For example, technological protection measures, TPMs, allow content owners to regulate access or regulate the use to which a consumer can put their digital content. So rights management, basically. Opportunities to exercise fair uses or permitted uses can be limited beyond normal user expectations and beyond what the law previously allowed for analog content. The provision of content in digital format and the use of TPMs and the added support that legislation gives to protect those TPMs in some jurisdictions effectively allows content owners to determine what limitations they're going to place on users' utilisation of their copyright material. It's possible that the future of copyright lies not in the legislation, but in contract rather than legislation. So let me give you some examples of where we might see AI and blockchain talking about code as law. AI-driven facial recognition technology is a good example where code governs behaviour. In Australia, the use of facial recognition technology in public spaces can impact privacy because it allows for the identification and tracking of individuals. The code behind the technology, including its algorithms and databases, will essentially determine what data can be collected and how it can be used. In this case, the code acts as a form of regulation that influences people's behaviour, either by discouraging anonymity or by enabling surveillance and data collection by various entities. Of course, people in the town square don't know what software is sitting behind the AI. One of the issues that's been in the news in the last 3 to 6 months or so has been around cameras that have emanated from China that have incorporated OEM, so original equipment manufacturer code, which is collecting and potentially sending information from those devices to third-party territories. Now, clearly that transparency piece is necessary for us to know how this works, but what is actually collected and where it goes actually happens as a consequence of how the code is written. And so it does beg the question, to what extent do we need to audit or look at code to make sure it complies with the requirements that we have? The blockchain example that I was going to give you of code as law was a project that has been on the books for about 7 years with the ASX. So the ASX, as many of you will know, is a stock exchange, and essentially a stock exchange these days is a technology company. The ASX's technology is a piece of software called CHESS, its clearinghouse system, which essentially recognises trades and makes sure that share registers are updated as shares are bought and sold in real time. Back when I was young, I can't believe I'm going to share this with you, but when I was first admitted as a lawyer, the stock exchange was a very different place from what it was today. It looked more like what you see on old TV shows. There were people screaming on the floor, yelling out prices if they wanted, that they were prepared to buy things for or sell them. People would match. They would then call up to the people who were called chalkies, who would write the prices on the board, and then those prices would be typed into pages that would be published in the newspaper the next day. Because everything was happening on paper, it took days for share trades to clear. Now, when CHESS was introduced, and Australia can boast that it was one of the first automated or computerized stock exchange in the world, when CHESS was introduced, then suddenly the time for those transactions to be cleared became shorter and shorter and shorter. So these days we boast a trade settlement time of 2 business days. Now, some time ago, 7 years or more ago now, ASX, wanting to maintain its lead globally in the provision of technology for stock exchanges, its technology is one of its main revenue sources, was looking at replacing the old CHESS system, which was developed in the 1990s, and replacing it effectively with a blockchain solution. And when you think about what a stock exchange is and essentially what share registers are, just ledgers, that makes a lot of sense, right? And so this project was really around identifying ways to use blockchain and smart contracts to determine the rules for creating, verifying, and recording transactions on a decentralized, secure, and transparent digital ledger. Unfortunately, they've since abandoned this project, so I had to come up with a better idea. Now, I'd love to understand more about why they abandoned it. They cite a range of things, including technical difficulties. I think there was a lack of understanding, and it's certainly, as we know, blockchain transactions don't happen quickly, and stock exchanges, by their nature, are incredibly conservative organizations. So while I would never say never, I think we're going to need to see much more use of blockchain in conservative fintech environments before it's going to be successful in an ASX or a stock exchange example. So again, probably a better way to think about it is the use of a combination of blockchain-enabled smart contracts and Internet of Things devices, say in agriculture. So we can imagine an environment where essentially the smart contract says if the soil becomes the pH becomes a particular percentage, or it is too dry or too wet or whatever, that you release a particular kind of fertilizer, micro dosing fertilizer, for example. So the contract is, if a particular soil result comes back that the sensor shows, then you should feed the soil in a particular way. And so what happens, the law of what happens here, is completely autonomously regulated by the smart contracts on the blockchain. A key way of understanding Lessig's theory is understanding what is charmingly referred to as the pathetic dot. So the pathetic dot theory. So this theory describes how four forces regulate human behavior. Usually humans are the pathetic dots. And these forces are the law itself, so traditional law, social norms, market forces, and architecture or technology is another way of saying this. And effectively, architecture in the context of the internet, in the context of technology, is the underlying code that makes the hardware or the software work. The pathetic dot represents an individual subject to the four forces, which collectively shape the actions that they take and the choices that they make. So let's have a look at what this might look like in a hypothetical situation. So I've just chosen, let's imagine a company that is using AI as a recruitment tool. So think about what that means. Clearly, there are laws that apply. They include things like anti-discrimination laws that impact the choices and the reasons that people can say yes or no, particularly say no to particular candidates. Society also has expectations in relation to fair treatment of candidates and fair processes in place when people are applying for jobs. Markets can be very much driven by reputation and competitiveness. So a company's reputation and competitiveness in a job market is going to rely on its hiring practices. And of course, things like Glassdoor, LinkedIn, Seek, and other online platforms are basically sharing information about these organizations with prospective hires. But lastly, then it comes down to the code. So the code, the architects of the code have choices in the way that they write it and what they do. So there may be unintentional, most likely, bias in the code, or the code itself could be written to promote fair hiring or to challenge bias or expectations in some way. And so these four areas work together to drive the way in which this technology could be used by an organization. And in this particular case, the pathetic dot could be the company that is using this technology, or it could be the company that is promoting and developing the technology. Let's think about another hypothetical and pathetic dot theory, how it might apply to blockchain. So here I'm thinking maybe about a company that uses blockchain-based supply chain solutions. And once again, these four forces would apply. there's the law. All companies need to comply with Australian trade regulations, consumer protection laws, reporting requirements. They need some of the laws or the structures that they need to fit into will be international, the international trade laws, and the processes that have been adopted by logistic companies and shipping companies around the world to make trade work. Of course, there are also social norms. The company will be expected to maintain ethical sourcing practice and to uphold environmental standards. They're likely to have to report on their modern slavery requirements if they're an Australian company. By the way, when I said requirements there, that made it sound like there was a requirement to have modern slaves. I think it's terrible language. I think all slaves, modern or traditional, are bad. Not the slaves, but the slavery. And there are requirements under Australian law for companies of a certain size to report how they ensure that they don't inadvertently incorporate modern slavery in their supply practices. Market forces are also relevant here. The company's reputation and competitiveness relies on the transparency and efficiency of its supply chain. And so that means that the architecture or the code can be written in ways to enable secure and transparent tracking of products, promoting trust and accountability in the supply chain. This is clearly one of the things that blockchain has been designed to do, right? So it's one of the reasons why there are so many use cases for blockchain in a logistics setting. It's worth noting, though, that what the blockchain can do is verify that the information that went in at the beginning hasn't changed. Rubbish in, rubbish out, right? Junk in, junk out, unless and until we can solve the problem of ensuring that what actually goes in at the very beginning is absolutely true and verifiable. All we can really do with a blockchain is know that the information that went in at the beginning hasn't changed, which is not exactly the same as knowing that it's true. Once again, in this setting, the pathetic dot would be the company. The company which is influenced by the four forces in the supply chain management and overall operations. Once again, it could also be the company developing a supply chain solution using blockchain. And ultimately, thinking about it that way shows you that the pathetic dot itself might actually be an actor in the process, but the other forces will effectively impact the choices that it makes about the way that the code is developed. Questions, concerns, frustrations, or compliments? Look forward to talking to you about all of these things in the tutorial. I'll see you then. Cheers.